Which of the following functions are invertible on the domain 0 pi? What does invertible mean? Invertible means you're allowed to take the inverse. Sorry, that took me a second there. You're allowed to take the inverse. To find out if something's invertible, you take the horizontal line test. And you might be thinking, is that the same as the vertical line test, but horizontal? So what we have to do is we have to graph each of these and see if each of them pass the horizontal line test. Let's graph each of them first. I'm going to put U in red. So one is going to be, and again, I only care about between 0 and pi. Regular cosine starts up here, but negative is going to start down here, so I kind of need a lot more than that. Okay. If it's 2 pi, that means the period for this one is going to be 2 pi over 2, so the period is going to be pi. So if it starts down here, it's going to repeat at pi. So starting down here is going to have it peak up here somewhere and then come back down. Okay, so that's what the graph of negative cos 2x is. Okay, let's graph sine half of x minus theta, or pi. Now, this gives me a little bit of a stretch shrink thing going here where the period is going to change. So the period is going to be 2 pi over a half, multiply the top and the bottom by 2 to get rid of that half on the bottom, and that gives me a half of 4 pi. So it stretches this out. Okay, so 2 is going to stretch it out and move it to the left pi. So normally what I do is sine starts here, but now it's going to start here at negative pi. Actually, I apologize. It starts at the right of pi. So let me do that. So let me scooch you over. It's going to start to the right of pi. So here's pi, okay? And it's going to repeat every 4 pi. So sine starts here, comes back up, dips under. So I don't need to go that far. Here's 3 pi. If it repeats every 4 pi, then that means it kind of goes up and comes down at 3 pi. That's a bit too much already because I only care about going to pi. What matters here is this is going to dip under and freeze. So the important thing here for this guy, let me scooch this over. The important thing here for this guy is just that much. Okay, so when I do the horizontal line test on that guy, I'm only going to do that much. Now for 3, it's tan half of x. The period for a tangent function is slightly different. It's pi. So pi over a half means I multiply the top and the bottom by 2. So that gives me a period of 2 pi. Okay, tangent, when graphed, right, goes like this. And it has a period where basically the period is normally a pi. Now it's 2 pi. So normally for a tangent, I would have a vertical asymptote at pi over 2, and I would start here and go up. But now, right, if I start here and go up, since the period is now stretched out and doubled, I have a vertical asymptote at regular pi instead of pi over 2. Now what I need to do is apply the horizontal line test to each of these guys. So when I apply the horizontal line test to 1, it fails, which means 1 is not invertible. When I apply the horizontal line test to 2, it works. When I apply it to 3, it works. So my answers here are not going to be 1, but 2 and 3. Those are the only ones that are invertible because it passes the horizontal line test. Oh, please do like and subscribe. I need it.